So today we're starting the law of cosines. Okay, so we've done the law of sines. Now we're starting the law of cosines. Now there is a law of tangents as well, but we're not going to be going over that. Okay, so law of cosines. So just like the law of sines that we've already learned, we've figured out that there are only certain situations that we can use the law of sines. We can't do law of sines unless we have at least one full ratio to set up to find the fourth piece of information. Okay, so we can only use it for angle angle side or angle side angle as well as side side angle, which is our ambiguous case. So when we have the other two cases that we've talked about, side angle side or side side side, we have to use the law of cosines. We have no choice. Okay, and I'll show you what I mean in just a minute. Okay, so the law of cosines looks like this. If you have the triangle ABC, a squared equals b squared plus c squared minus 2bc cosine a. Should look sort of familiar. A squared equals b squared plus c squared. That's part of the Pythagorean theorem. Okay? It's not c squared equals a squared plus b squared because we're not dealing with a right triangle here. But you can see this has part of it is to do with the Pythagorean theorem. And then this other part here should look familiar. It looks very similar to the area of a triangle, oblique triangle equation, except that one was 1/2 and it was sine of the angle. Okay? But basically this is a production of the two. Now, I've given you all three of these, okay? But really there's no need for all three of them. Because what we've been learning is that the way we name a triangle can be changed. So for instance, this is the triangle ABC this way. But what if I said, oh wait, I want it to be this triangle. I want to put A here and B here and C here. Isn't that still the triangle ABC? And as long as I change the angle and the side name, I can name it however I want it to be. So really, I generally use this third one because it fits my idea of the Pythagorean theorem. Okay? But, like I said, it doesn't really matter because you can rename your triangle whatever you want to. Okay? Now, also, using the law of cosines, we can find just an angle measure. So for instance, if we have the side, side, side case, and we need to find an angle, we can use that law of cosines and solve it for the angle by doing just some simple algebra. Okay? So if I start with this one, and I solve for cosine C, first thing I do is move this negative one over to make it positive, move the c squared, make it negative. Then divide both sides by 2ab. I get cosine c equals a squared plus b squared minus c squared over 2ab. Okay? And this is if you have all three sides. So now I have all three of the sides on one side. I have my cosine c on the other side. But the last thing you have to do is to make sure, since I'm trying to solve for the angle C, you got to do that inverse cosine to both sides to finally find your angle. If not, you're going to end up with some kind of decimal. Okay? So law of cosines is really, really simple. Okay? It's just a formula. So let's work our first example. So I have this triangle right here. I have X, Y, Z, my triangle. Okay, now they gave me two sides and an angle. Now if I saw this, well, the first thing I'd look is say, okay, do I have the ambiguous case? Is this the law of sines problem? Well, it's not, because this is not the SSA. This is side angle side. So this is not the ambiguous case because I have the included angle. And as soon as I see that, I know that I'm dealing with the law of cosines. Okay? So we're trying to find side X, which is this side right here. Okay? Now again, you could rename this ABC if you want to, but I'm not going to worry about it. So I know it's a law of cosines problem. So basically all I do is I use the equation. Okay? So I use it to fit my situation. So I get x squared equals y squared plus z squared minus 2yz cosine x. This is my law of cosines for this triangle. Plug in what I know. So I plug in all the measurements. And then at this point, it's just a calculator problem. So you plug it in your calculator, then you take the square root because this is x squared. So you get x, and you find that x is approximately 18.9. So we always round to the 10th. Okay? That's it. This is the law of cosines. You see how easy that is? Okay? Yep, this is basically you find the equation, plug in what you got, find the answer. Okay? This is a simple fetch problem. Okay? So, I want you guys to work this one. So, pause it and see if you can find side R, and then unpause it when you're done, see if you got the correct answer. Okay, so again, this is side angle side. So you're going to use the same equation, plug it in, and you should have gotten 22.7. Okay? Now, this problem here, okay? Again, make sure that you're doing the law of sines or law of cosines, okay? So they're asking us to solve this triangle, which means we have to find all the missing angles, all the missing sides. Okay, the last two, we just asked you to find one missing side. So again, this is side angle side. So since we know the measure of two sides and the included angle, we're going to use the law of cosines. So we start off by using law of cosines, just like we did on the first example. Plug in what we know. Let the calculator do the work for us, and we can find side F, which is 46.9. Okay? Now, once I have side F, I now have side F and angle F. Since I now have one of my ratios, I have an angle and one of the sides, I can switch and use the law of sines. I don't need to do the law of cosines to find the other angle. So that's what I'm going to do. Since we have a ratio, we're going to use the law of sines to find the measure of angle D or E. Okay? So here I am. I'm switching to the law of sines. Since sine F over F, that's the ratio I have, I'm going to use it. Plug in what I know. Cross multiply. Plug it into the calculator. And I find angle D, which is approximately 23 degrees. Okay? And of course, since I know angle D now, I can find the other angle because I have two of my angles, and we use the sum of a triangle to find the third one. So you take 180, subtract the other two, and you find angle E is approximately 12. Okay? So really, when we do a law of cosines problem, we're generally doing it just one time. Okay? And then we switch to the law of sines if we can. So this is the solutions for my triangle. Side F, angle D, and angle E. The other three pieces of information. Okay, that's the law of cosines.